in your note packet, which is 4, 4. 4, 5. And so I want you to start off by answering this. Now, humps is just another word for turns. Okay? So try to answer that, and I'm going to give you just about a minute and a half to do that, and then we'll go through it, and then we'll go through what the lesson of today is. Today is our last building block. All right, so 4, 2, 4, 3, 4, 4, and 4, 5 are all building blocks that then with 4, 6 we put together. So just try to get an answer down for this one.
Like one that like changes direction. Yeah, where's Alan?
No. Parentheses around scoops. Because you could have one turn or you could have all four.
Like school fight?
Chase, word is word. Stop talking. Alright, so that's all the time I'm going to give you. This is how quick I want you to go through it. I want you to look at x cubed and minus 5x and go, okay, that is an odd degree, that's degree 3, and it's positive. So I actually look at this as just that, which means my end behavior is going to look like this. So now I can go ahead and answer these two problems. So my end behavior, right, as I go to the right, this goes up. So I'm going to say that's positive infinity. So I'll even put the infinities on the graph here. So up and to the right is positive, down and to the left is negative. So that one's done. When I look at going to the left, I'm going down. So this is going to be negative infinity. Done. Okay? So you could even go quicker than that because you're not talking about some of those pieces. Now when we get to how many turns there are, well, degree 3, what are the possible number of terms for a degree 3? Not 1 and 2. 2 and 0. So I could have 2 turns. So it could look like this, or it could look like that. Now, this function right up here, we're going to graph it, but we're going to graph it with Desmos, and you don't need your Chromebook or anything like that. Like I have the picture, we're going to just graph it, all right? So this is the picture that you're going to graph on your graph. So these points, I need you to get on there. Now, the negative 2.236, we can approximate, we can just go negative 2.2, okay? The points up here, we can approximate, and we can just go to the 10th place, all right? So when you're drawing this curve out, just go to the 10th place for those numbers, all right? And I'm going to draw it on the whiteboard so it's there if you take a little bit longer. So like I said, the graph is there on the whiteboard if you need a little bit more time to just polish everything off. But so we're gonna start kind of connecting things. So where's your first turn? What are the coordinates of your first turn? What are they? Yeah, so our first turn is at negative 1.3 and 4.3. So I'm going to draw an arrow to that. Boom, it's right there. That's my first turn that we're looking at. Was it a relative max or relative min? Well, what does relative mean? Relative means that we are only looking at a very tiny portion of the graph. So if I went ahead and I looked at just right there and I blacked out everything else, that'd be a relative max, okay? It is not a maximum for the entire function, which is what we call an absolute max or min. That has to be for everything. Relative means, though, just in that little tiny window, okay? You can also call it a local max or min. So I'm going to get rid of all of that extra stuff that I put there. But it is going to be a relative max. So was it an absolute max or min? No. Now, instead of writing this out as a coordinate pair, I can also write this out as a max of 4.3 when x equals negative 1.3. That's actually the preferred way to do it. However, sometimes we ask you for a coordinate pair, like where does it happen and all that stuff. Sometimes we ask you to write it like that. So you want to be able to do both, okay? So I'm not going to do that for every single one, but I will throw it out there a number of times. So that was our first point. Where is our other term? What's the coordinates of the other term?
1.3,
Perfect. And I'll draw my arrow over there, so it's right there. Is it a relative max or a relative min? Relative min. So I'll circle that. You can also write min down. It is not going to be the absolute max or min because I can look over here to this part of the curve and it continues to go down. So there's always a lower point. So it's not going to be an absolute. So no. And again, I could also write this. I could say it has a min of negative 4.3. I'm talking about my height right there. And I could write it like this, at x equals 1.3.
Is that required on the test?
Or get there, okay? Don't worry about it. We're going to make the notation very clear. So you don't have to stress about going back and forth. I just want you exposed to everything on it, okay? Any questions there so far? All right, I'm going to slide down here. Possibly. So, did the function have an absolute max or min? No. So I'm actually just going to put one big no and be done with it. Now, we looked at one odd function. But based off that one odd function that we looked at, do we think that an odd function will ever have an absolute max or an absolute min? No. We're actually not going to. Because think about it. If I look at end behavior, if I have my arrows like this, I don't care what happens in the middle. It could go like this forever and then connect. But there's always an arrow going up. So there's always a higher point. And there's always a lower point. So it makes sense that there would not be. So will odd functions ever have an absolute max or an absolute min? No. They will not. It just never is going to happen. That's what we're assuming right now, and I'm going to say that's a really good assumption. Questions? All right, look at it. If you're good. All right, number 2. We have a function. It's talking about end behavior. and I want you to try to answer that first part again. So this is reviewing 2, 3, and 2, 2, and part of 2, 4. So try to answer that. Julian basically goes, even functions go like this or this, odd functions go like that or that.
How do I know if it's like that or that?
Positive, positive. Negative, negative. There's a chart in that lesson. I would recommend just looking at that.
Okay.
Don't really need much else.
Okay.
What are you doing?
When they always promise my teacher. Also, I'm being wrong.
So end behavior, degree 4, kind of already threw it out there. It's going to look like this. So I'm going to put that down for both of these. Now, as x goes to the right, as x goes to the left, we get the same answer, right? They're both going down. What is down in terms of infinity? It's negative infinity. So I'm going to put negative infinity for both. Now, how many turns can I have? How many? 1 or 3. Perfect. So we got 1 or 3. So that's my 1 turn. That's my 3 turns. Now, I have the graph again for you. So I'm going to slide down. I'm going to put it on the whiteboard as well. So if you need a little bit more time. But again, let's round these things to the 10th place. So I'm going to slide down. This is our graph. I'll draw the points a little bit bigger over here. So I'm going to go with negative 2.5, comma 0. We'll have a positive 2.5, comma 0. I got 0, 0. And then it looks like 1.7, positive and negative. And both have a y-coordinate of 9. All right, what's the first turn? What's the coordinates of it? All right, so we got negative 1.7 and 9. I'm going to draw over here. So is it a relative max or a relative min?
Max.
It's a relative max. Now, the other thing I'm going to throw out there is anytime that you have a turn, you have to have a relative max or a relative min. Anytime there is a turn, you have one. So this is a relative max. Is there any y-coordinate that is larger than 9? No, there's one that's equal to it, but it's not bigger. So I'm actually going to say that this is an absolute max. Now, this one I'm not writing both options out, but just realize they're still there. Where's the next hump? Where's the next turn? 0, 0. And that's really good practice. You always want to go left to right. So I started here, and then I went to the next one. Sometimes people like to jump straight across, but we always want to go left to right. So 0, 0 is the next one.
Does it become a problem if you do?
It doesn't. The only thing is sometimes people forget to go back. But it's not really so, like, I'm not going to mark it wrong. But that's about it. So I'm going to draw my arrow over to it. Relative max or relative min.
Oh.
Minimum, yeah. And then, is it the lowest point of the entire graph? No, it's not. So, I'm just going to put a note right here. The last one then I'll just put down is 1.7 and 9. Draw my arrow over to it. Is it a relative max or min? Should be max for both, yeah. So it's going to be a relative and an absolute. So we actually have two absolute maxes, okay? Or I should say we have one absolute max that happens at 2 different points. So did the function have an absolute maximum value? Yes. Now what is it? 9. That's it. It's when it's talking about the max or when it's talking about the min, it is only talking about the y-coordinate. So it is talking about just 9. So it does not have an absolute min. So we talked about odd functions last time. Now we're looking at an even function. Will even functions ever have an absolute max? Or, sorry, always have an absolute max or an absolute min?
Yeah.
They will. They're always going to. They're going to have one. Okay? At least. So I'm going to say yes, always. Questions? All right, you flip the page. So I got the graph right here. Okay, you can see it. And then I also have the graph right here for number 3. So it's looking 0, 1, 1.02, 6.01, 1.4, and 0. So you get the whole page. And I'm going to give you about 4 minutes. And we're going to see how we did. So you got the whole page. The graphs are sitting right there. And you got to fill out everything you can. So do your best.
What graph are you talking about? We'll look at for that.
Go back in your notes to 4, 2. Right.
This one?
Table. Okay. This is positive 3 coefficient. This is positive number.
Okay.
This is like x squared, x to the 4th, x to the 6th.
Okay.
That's always going to be the little x-y-axis there. Put in the x-y-axis there for all of these. So if it's even and it's positive, you have an arrow going up here, an arrow going up here. Now we don't know what's happening in the middle, but we know that these two things are happening. So it's negative and even, down and down. It's odd. It's positive, starts here, starts low, and positive. Think about if you do a line between x, y, so negative, that's high, that's low. Think about if you draw a line,
you find the colors?
So it's always one less than that, so then 4. And so that's the first possibility. And then you go down by 2, so that's 4, 2, 0, 1.
Is that all correct? Is that maybe 0, 2?
No, these are all positive. Yeah, that's negative. But you got the 10. Yeah, you did.
So, but these are facing the wrong way.
You just put them. So 0 is fine. You don't have to erase.
Like this.
Yeah.
I do that.
So the first part of that problem was up on the board. I'm going to give you a little bit more time to finish the rest of it. I know we have a decent start on it. Thank you. All right, let's talk about it. What is my first term? Where is it? What is it?
0, 1.
0, 1. So I'm actually also going to write this like I would on other times. So I could say this is 1 when x equals 0. And what is this, a max or a min? It's a minimum, so it's a relative min. Is it an absolute? No, it is not.
So relative min.
Now I can also call that local again, just as a reminder. What is the other hump that we have? Yeah, pretty much. I'm going to go, yeah, I'll just go with 1 and 6. That's fine. So then, was it a relative max or a relative min?
Max.
That's right. So it's a relative max. And again, I could write this out as 6 when x equals 1. So was it an absolute max or min for the entire function? Did we have one?
No.
No. So actually can just cross this off and put no for both of these as well down there. And you know, that kind of goes along with the idea we had on our first one, which was if you have an odd function, you should not expect to have an absolute max or a min. Okay? Any questions? On your homework today, you do have to use Desmos. So, like I gave you the graphs today, you're going to actually have to plot the graphs in Desmos. So you're going to have to type it in. So if you get stuck on typing them in, I can help you with that. But try to get that done right away, because I really want you to have this done, the building blocks done, so then when we get to Monday, we can put all the pieces together. Okay?